and welcome to Space here from the European Astronaut Centre in Cologne. And this month we're talking about this, the Columbus module on the International Space Station, Europe's research centre in space. For the past 10 years, it's been used by astronauts to carry out experiments on themselves, grow plants, and even develop new metals. Let's find out more.
That the weather's good, and I'll just...
10 years ago, Columbus took a shuttle ride to space. Europe's new space laboratory flew into orbit and was carefully bolted on to the International Space Station. Today it's a busy workplace and the favourite quarters of recently returned astronaut Paolo Nespoli.
To a European astronaut, it's a little bit like home. I mean, by definition, by default, when a European astronaut flies, he or she is responsible of the Columbus or the laboratory itself, which means maintain it, make sure that everything works.
ESA astronaut Leopold Eharts oversaw the installation of the 10-ton module back in 2008 and shows us around the astronaut training mock-ups here in Cologne.
I was lucky to be part of this mission and to be the first European astronaut to get into Columbus and turn on the lights. This is quite like the real place on board the International Space Station. So the module inside is very well organized. This is a scientific laboratory, so of course we have scientific facilities. Here we have a microgravity environment which is permanent, so we can do experiments with a long exposure to microgravity, and there is a continuity in the science.
Being able to carry out and repeat experiments has yielded groundbreaking results, like this research into how plants cope in weightlessness. The scientists behind the research want to develop systems to produce food for astronauts on long-term missions.
Right, and then on the right there too.
We actually can grow plants in microgravity or weightlessness. Plants, they can adapt, they can germinate from seed, they can go through the whole life cycle and produce new seeds. So actually it can adapt quite well to these conditions, and that's quite fascinating.
Another experiment on Columbus has seen life forms from Earth exposed to the universe outside the module. They were fixed in trays in the vacuum of space for a year and a half to test how hardy they really are.
3 of these trays went inside the Expose-E mission up to the ISS. Together with these trays, we sent up different microorganisms from bacteria up to lichens and also some larvae of different animals. And indeed, when they came back, several of these organisms survived.
The International Space Station began with Russia's Zarya module in 1998 and now has science labs from Japan, Russia and the US alongside ESA's Columbus. The astronauts on board follow a busy schedule of experiments, many of them on themselves. They test how their muscles, bones, blood and brains react in space. One surprise finding is that astronauts' brains have reduced electrical activity and performance in space, and nobody knows why. Meanwhile, this team has been tracking radiation, one of the greatest dangers astronauts face. In an experiment called DOSIS 3D, they mapped how radiation varies around the Columbus module and found other factors make a difference too.
Since DOSIS 3D is running over a very long very long time, let's say it like this, we could also see the changes in the radiation environment due to the fact that, for example, the space station was lifted up by 70 kilometers in altitude. That changed the radiation environment. And then we could see variations due to the solar cycle, depending if the sun is very active or not.
Experimenting in a weightless environment is unique, and Columbus is the only place these scientists can study how new metal alloys solidify without the influence of gravity. Their instrument is controlled from the ground, but they rely on astronauts for essential hands-on help.
Astronauts are important for us. They install the facility and they, for instance, change camera systems. So for different experiments we need, for instance, cameras with high spatial resolution, or for other experiments we need a high frame rate. So this change of camera has to be done by astronauts.
That cooperation between astronauts in orbit and scientists on the ground will continue, with the ISS expected to remain active for another 10 years. And their research will inform exploration of the Moon and later Mars.
The International Space Station is also a very good tool for preparing the future of exploration. It can be on the medical side, on the studies of the human body, but also on technology, robotics, and all these kind of things which will be used in future exploration.
These activities are in preparation for plant biology research.
In the meantime, ESA astronauts home from home in orbit will continue to push out big science from a small lab.
Find out more about how extended exposure to weightlessness impacts many systems of the human body. The experiment neuromapping, which has another round of data gathered from the crew.
It's incredible that in a space relatively small, because at the end it's a module, it's like a room, you can do anything you want that has to do with science in space.
And now to a new part of the programme in which we're taking your questions about the universe and putting them to the experts using the hashtag AskSpace. So our guest is Frank de Winner. Thanks very much for being with us. You're head of the European Astronaut Centre and an astronaut yourself. The question we've had is from Felician Cadar from Romania, who'd like to know about this ESA concept of building a village on the moon.
Well, the first step into this moon village concept, I would say, is what we are doing today, for example, with our partners of NASA, building the Orion spacecraft and the ESA service module to the Orion spacecraft to be able to fly to the moon. We are working with our Russian colleagues to provide landers on the moon to look for example, water on the moon, because if we want to be there on a sustainable way, we will have to explore resources on the moon, oxygen, hydrogen, maybe to refuel rockets.
So tell me in concrete terms what's actually happening here at EAC.
Here at EAC, we are actually looking at the operational concepts of such a moon village, of such a lunar base. How will we build the shelters there? We cannot bring them all from Earth. We will need new resources. Can we use the regolith, the sand that is on the moon, to build infrastructure? How would this interaction between humans and robots work? How will we build the life support systems? How will we produce food on the moon? This is what we are looking here in EAC with the spaceship EAC concept.
Well, that's all we've got time for in this programme. You can send your questions about the universe using the AskSpace hashtag, and we'll try to answer them. And in the meantime, follow other space news on euronews.com.